Assalamualaikum and hi. Now let me continue to another topic that is important in DC biasing, which is operating point. Before that, let me explain about the DC biasing. The analysis or design of a transistor amplifier requires a knowledge of DC and AC response of the system. It means that there are two components in the analysis or design of the electronic amplifier. The first one is the DC portion for large signal. The second one, the DC-AC portion for small signal. The DC level of operation of a transistor is controlled by a number of factors, including the range of possible operating points on the device characteristic. Do you remember what is device characteristic? The device characteristic is a graph that has IC and VCE voltage. BJTs need to be operated in active region used as amplifier. The cut-off and saturation region used as a switch. For the BJTs to be biased in its linear or active operating region, the following must be true. Base emitter junction must be forward biased with 0.6 or 0.7 volt. The base collector junction must be reverse biased. These are the important basic relationship for a transistor. Do you still remember what we have learned from the previous lecture? The BE equal to 0.7 for NPN transistor, VEB equal to 0.7 volt for PNP, or normally we say that VEB equal to negative 0.7. The IC equal to IE, and IC also equal to beta IB, the IE equal to beta plus 1 multiplied with IB, and finally IE equal to IC plus IB. Operating point is a fixed point on the characteristic and also called the quiescent point or Q point. The DC current and voltage establish an operating point on the characteristic that define the region, which are active, saturation, and cutoff, that will be employed for amplification of the applied signal. The biasing circuit can be designed to set the device operation at any of these points or others within the active region. The BJT device could be biased to operate outside the maximum limits, but the result of such operation would be shortening of the lifetime of the device or destruction of the device. We can select many different operating areas or points in active region. The chosen Q point often depends on the intended use of the circuit. This is the device characteristic. As you can see here, there are 4 Q points: A, C, B, and D. We know that this is saturation region and this is cut-off region. The white region is a active, or we call linear region. For the Q point A, the current equal to 0 and the voltage VCE also equal to 0. So at this point, it is not suitable for transistor to operate. For the C point, the concern on non-linearities due to IB curve is rapidly changes in this region. As you can see here, this blue line represent the IB. So IB is rapidly changes in this area, and this point is not really good enough for the transistor to operate. The B point is the best operating point for linear gain and largest possible voltage and current. It is a desired condition for a small signal analysis. So take a look here. B is at the center of the active region. The D point, the device operating point near the maximum voltage and power limit. Okay, this one also is not a good point because it really near to the maximum limit for the device. Operation in the cutoff, saturation and linear region of the BJT characteristic are provided as follows. For the saturation region, the base emitter junction is forward bias and base collector junction is forward bias. For the active linear, the base emitter junction is forward bias and the base collector junction is reverse bias. The cut-off region, base emitter junction is reverse bias and base collector junction is reverse bias. Recall back, for this transistor, where the base and emitter junction is here and base collector junction is here. So every time we mentioned about the saturation, active and cutoff region, we must remember that the transistor is in each condition with the base collector junction and base emitter junction must be follow this biasing.